recorded,
Recording in
right?
progress.
Sometimes he might have taken 30, 29, 31 minutes, 32 minutes, 33 minutes, like that, right? So whatever time taken, it is recorded, right, in a one column, which is now it since it is minutes, it is a metric variable. For that variable, I have taken a average, right, mean. Then I have taken a standard deviation, right. So my mean, okay, so my mean is, let us assume that mean is 30, right? So my mean is I'm going to use one more, probably you are all teachers, you might be knowing, right? So I will use that also, right? So now, right. So my mean, right? So mean equal to 30, right? Let me put in color also, let me put white. So the mean equal to 30, mean equal to, okay, 30. Okay. Then the standard deviation is 1, right? So now, now what happens? Now what happens? So now, okay. So now, for example, now what happens? Mean, right? Mean. So that is mean. So let me take. So now mean, right? Which is so many screen in between. What to do, right? So the mean, which is 30, is not writing. Let me write. Okay. So mean 30, right? Plus or minus 1 standard deviation, which is 1, right? Plus or minus 1. So which means 29 to 31 minutes, right? If I take, you know that maximum time he might have taken 30, right? So he might have taken sometimes 31 also, sometimes 29 also, right? So now if I count how many times he has taken 29 and 30 and 31, now it says this will be 68 times, right? So out of 100. So suppose if I take 28, which means 232, right? Which means mean plus or minus 2 standard deviation, right? Mean is 30, this side 2, this side 2, right? So now if I take 28 how many times, 29 how many times, and okay, so if I calculate that, so now okay, so that will be, okay, that will be 95 times, 95 times, right? Suppose if I take 27 to 33, 27, 28, 30, 31, 32, 33, then 99 times we might cover, 99 times we will cover, right? So normally it will go like this. Normally, so middle he will take more number of times. When you come this side and this side, you'll go lesser, because 31 little lesser, 27 it will be little more lesser, right? Because normally it will take 30. Sometimes, see, we cannot say we are not machines walk straight away, right? So these deviations are bound to happen. The deviations are bound to happen, right? So, but more number of times on the middle, a little lesser number this side, little. So that is why we say the curve will be like this. Then what is this 1%, sir? What is this 1%, sir? Right. See, what will happen is one day, that is we are conducted, Sivakumar sir has conducted on Sunday also, right? So the Sunday, here that gentleman has prefixed some appointment with somebody, right? But Sivakumar sir said, no, if you are not coming, no certificate. So he has come, right? So then before he could come, he has told that person, right? That person. So because he has fixed a program with that person, no. See, the program will get over by 8 o'clock. So I will come immediately. As soon as it is over, I will come. Okay, so wait. So then, okay, so he is thinking that in the mind, though he is sitting in the class, he is thinking that in mind. Now that also I have asked him to walk, right? He is moving, he has gone to the out of the gate and he was walking the road. When he was walking on the road, on the other side of the road, he has seen somebody. Right? Nandri madam, who is that person, madam? Hello, madam, who is that person? Okay. So she is that person, right? He has asked, So he could not believe. Like, how come this person? I've asked him to. So then what happened? He has ran and he has jumped in the center median, gone to the other side. He was like, who you have come? I don't know, how did you come? He was talking like this. He was going on talking. Then he said, no, you please wait here itself in the bus stand itself. So I will go and I will report and I will come. So he has come back. Now, how much time he has taken now? And then, madam, how much time he has taken? Nandri madam not there. How much time probably he might have taken? He might have taken more than not 32, 33. He might have taken 45 minutes, right? So is it acceptable behavior? Is it a normal behavior? No, it is not normal behavior. So this kind of behavior also bound to be there. So this kind of behavior we have to reject, right? So that is why these are all bound to happen. Okay. So that is why it will be like this, right? So see, when you operate with the 2 standard deviation, if it is less than here, if it is less than this, if it is within this one, we are going to accept. If it is beyond, if it is 45, we are going to reject. Why we are rejecting? It is not due to the chance, right? So the deviations are happening because of chance, because of in normal circumstances, all bound to happen. But this has happened because he has seen that girl. That is why he has taken more time. So this is not a normal behavior. This is an extraordinary situation. For a delay, there is a reason that has to be rejected. Okay, so that is what. So when it is beyond a certain, beyond the certain level, we are rejecting. Right? So the some difference will be within the range. So the difference within 1.96 this side, it is bound to happen. But if it is beyond that, there is a reason. So probably they are using more cell phone. That is why the usage is more. So we are rejecting. So this is the normal. Okay, so it is not something different. Normally is normal circumstances. Normally, what will happen? That is the normal. When you put the data, how the data will be distributed. That is called the normal distribution. So this theorem 68%, sir, how you are telling, sir? Somebody, they have done a research many times and they have reported. So this theorem, we call it a Sebisu theorem. That theorem says mean plus 1 standard deviation, this side 68. 2 standard deviation this side, 95, and 3 standard deviation, right? So this is what one example, right? Seeing a girl taking more time, all these things are going to happen, right? So now we will go to the logistic regression, right? Okay, so I think it is visible. It is visible. Very good. So I think this screen is visible, right? So carefully, please watch. It is a little difficult, but very easily I can tell. But you understand why it is happening, then you will be more happy, right? So first of all, this you should not forget. This you should not forget. Okay. So now our dependent variable is category, binary, 0 and 1. So my independent variable may be category and metric, right? So no normality assumption. So dependent variable is converted into probability. So which is again converted into odds. Odds is nothing but probability of occurrence divided by probability of not occurrence. So the occurrence may be anything, right? Probability of getting a seat and the probability of not getting a seat, probability of one person smoking, probability of not smoking. So the probability of having own house, probability of not having own house, right? So the probability of understanding, yes, understood instead of asking understood, not understood. So probability of understanding all this, right? So now, okay, so now this is called the odds ratio. This is called the odds ratio, right? So this is called the odds that you should not forget, right? So this is called the odds ratio. So the word odds you should not forget. So now, see now this probability of this word odds that you should not forget. Okay. Then okay, so then log of odds, log of odds. So that is why it is called logic. So my dependent variable is logic. That is why it is called logistic regression, right? That is why. So that is why it is logistic regression, right? So now, now the odds equal to odds, right? So this is a odds. This is a odds. So my odds equal to so this is my odds, right? So my odds equal to so now my odds. So my odds, this is my odds. Odds equal to E of, right? E of, right? So when you want to remove this E, when you want to remove this E exponential, when you take log this side, when you take log this side, right? So when you take log on both sides, when you take log on both sides, E will be removed. So my logic equal to, okay, A plus Bx. Normally this is our regression equation. So my dependent variable is logic. So yeah, is that right? So odds is probability of occurrence divided by probability of not occurrence. So why I say probability of not occurrence? 1 minus probability of occurrence is the probability of not occurrence, right? So now the point is odds is equal to e to the power a plus bx, that you need to, right? When you take logic, which is equal to a plus bx, that okay. So that one thing you should not forget. then the probability equal to odds divided by 1 plus odd. So P probability is equal to odds is e to the power a plus bx, 1 plus e to the power a plus bx. These are all I have already explained. Why I am taking odds, that also I have already explained, right? So now, okay. So now, first, right. So first of all, okay. So only two sentences, right? Only two sentences. But to explain that two sentences, I'm going to tell many things, right? Only two sentences, right? So, okay. So even if you are not understanding, no worry, that finally I will tell which two sentences you need to know, very, very importantly, right? So now let me take the data set. Let me take the data set. Okay. So is it visible, sir? Nandini madam.
Sir, yes sir, it is visible, sir.
Yes, sir, visible.
Madam, enna madam, where did you go, madam? Nandini madam, what is this, madam?
Sir.
Okay, so now, so my dependent variable is, okay, so this is my dependent variable, right? So now dependent variable is having, madam, dependent variable is having two category, right?
Yes, sir.
One is admission, right? Admitted, another is not admitted, right? So now the, okay, so whether you got a seat in foreign country, right? That is the idea, right? So whether he has a seat in a foreign country or not, right? So admitted or not, I want to know whether I will get a seat in that Harvard University, like that, right? So now what are the three variables I have taken is GRE score, right? Okay, your the GRE score, your score, and the your grade, and the rank of the institutions in which you are studied, right? So here I have not put a category, but it is a category variable, 4 ranks, right? 4 ranks. So this is a categorical variable with the 2 binary. So this is 2 are metric variable. This is my category variable. Rank is my category variable. You can see rank is my category variable, right? So now before now I explained what are the variables, right? Madam, explain what are the variables I have taken, madam?
Sir, 2 category variable, 2 metrics, sir.
No. What are the variable? Getting admission.
Admission, not non-admission.
Then GRE score means your own individual GRE score and their grade pass. And what is the institutions in which they have studied rank, right? So the institutions are divided into 4 ranks. So what is this one, right? Very good. Now, right. So now, first of all, let me take a frequency analysis for a categorical variable, rank, admission, right? Which is my dependent variable, which is a binary. Binary means 0 and 1. Yes or no, madam? What is binary, madam?
0 and 1, sir.
Very good, madam. So now let me put admission here. Let me put a frequency, right? So it's not a statistic. Why is unnecessarily statistics? Right. So now, right now, okay. So now how many people not admitted?